Ladies and gentlemen, dear organizers, thank you very much for organizing this DCC conference. My name is Rok Lobučar. I'm from Slovenia, Maribor, University of Maribor, Faculty for Mechanical Engineering, and I'm working in laboratory for production measurement, and we are designated institute for length in Slovenia. Today, I would like to present you this presentation with the title TraCIM Validation of Digital Metrological Data in DSI format. Here's the outline of this presentation. First, some words about SmartCom, then Digital System of Units, DSI, Digital Calibration Certificate, DCC, and at the end, the TraCIM validation. SmartCom is a project within European Metrology Program for Inventation and Research. SmartCom should integrate communication and validation of smart data in the Internet of Things networks. Consortium agreement was signed by National Metrology Institutes, NMIs, designated institutes, DIs, and different companies. The vision of the project is that it would develop and establish the base of ambiguous, universal, safe, and uninformed communication of metrological data in the Internet of Things and Industry 4.0. This world map shows different regions of metrology organizations like CIM, Euromed, Afrimed, and so on. Basic SE units are presented in this colored circle on the left side. All of these organizations accepted the International System of Units. So at this point, we can start to setting up the digitalization of metrology data. Now, what are the requirements for the SmartCom project? The system should be machine readable and universal, so machines could communicate with each other. The system should be ambiguous and safe, and of course, easy to understand. Here are the basic SI units, like kilogram, meter, seconds, ampere, Kelvin, mole, and candela. But also some other things should be taken into account, as VIM, International Vocabulary of Metrology, GUM, Guide to the Expression of the Uncertainty in Measurement, and CODATA. This is the Committee of Data for Science and Technology. SmartCom should support interoperability only on the basic level. There are a lot of different formats that are used, and DSI should help to speak a common language on a basic level. These are the minimum requirements, and in the future, all formats can base on this or the DSI. Which metadata should be available from a metrological point of view. If we take a look to a quantity reel, this is an example of minimum requirements for this quantity. We should take into account different documents or regulations from the left side. And if we take to look for the real quantity and this table, we can see that there are different components within it. There are some mandatory and optional. For basic real with expanded measurement uncertainty, the mandatory are value, unit, and expanded uncertainty. And optional, the label and date time. For the basic real with coverage interval, they are mandatory value, unit, and coverage interval. And optional, label, and date time. Okay, now some word about digital calibration certificate. Here on the right side you can see the regulations, and so we get the standards and norm. For DCC we also need administrative data, they are regulated, result of calibration, regulated and not regulated, and then comments, not regulated, and analog documents. These are human readable. This is the tree structure, and then we need an exchange format. This format should be internationally accepted and recognized. And it should include also cryptographic signature. All of this is needed to build a digital calibration certificate. Now we came to the smart convalidation. We know something about DSI and what is DCC. Interconnection of the data between DSI and DCC is presenting like gears and should be validated. And we need a system to validate this data. For this validation, we use TraCIM service. TraCIM service is traceable, computational intensive metrology. On the left side, there is service provider with consortium of national metrology institutes. Then we have here internet-based test service with validation of algorithms, data metadata, and digital calibration certificate. On the right side, there are the service users like industry, calibration laboratories, and metrology institutes. The main thing is here machine-to-machine communication. Now for the TraCIM validation, different quantities that could be used in DCC are presented as Olympic rings. These are univariate, complex, multivariate, real, and vector. And then we have also units. What kind of units are presented in DCC? We get a medal from the TraCIM service. We strive for this, that digital future should be more on the right side. It means closer to the platinum medal. One more explanation. On the left side, we have a digital calibration certificate with a gold medal, an expression of different medals. Gold medal means that there are not only base SI units in this digital document. As we see in this table, this document also contains some hybrid elements, prefix, or SI-derived units. Here is an example. If we have millimeters, and in the digital certificates, then we would get a gold medal. But we can express a millimeter as a meter with an exponent. So in that case, it would be platinum. Here is the basic concept of the TraCIM service. We have human readable information with temperatures in Celsius, expanded uncertainty, coverage probability, coverage factor, and probability distribution. Then we need to convert this human readable information into machine readable information. This machine readable information is sent to the TraCIM service, and from the TraCIM service we get a test report. But there is another thing to do. We have to validate the TraCIM service. Why? Because to guarantee the correct functionality of the TraCIM and to help providers to maintain the TraCIM server system. How we do that? This is automatic testing of TraCIM from a set of XML files on a client side. A lot of different kinds of DSC data and elements are combined to build a big data sets. And combinations that have been sent to the TraCIM server. And of course, should have capability to analyze this output and input results. This program is built in Java because Java is platform independent. Here are the main steps for validating the TraCIM service. On the left side, we have a set of XML files. These are randomly sent to the TraCIM server. We get a test report with a medal from the TraCIM service. And this result is compared with the expected result. And if both of results are the same, then the TraCIM service is successfully validated. So, if I'm more interested in some details, SmartCom team prepared some documents and brochures about DSI, DCC, and TraCIM. Now I finish my presentation with the SmartCom logo. Thank you for listening. Bye.